Oh, now there's the excitement we wanted for surface area. Okay, so what we're doing here is we're transitioning from kind of the elementary school way of thinking into using our formulas and looking for a more efficient process here. So what we've got going on is we're going to go back to our nets, but then we're going to show how we have a formula that we can actually end up using for it. Okay, so first things first, the whole net business here. All right, if we were going to draw out a net of what we were going to end up using, what we would end up seeing here are, we'd see a row of rectangles that would represent what we refer to as the lateral area. Now, the lateral area is the area that wraps around it. We have the bases, the top and the bottom, those are considered the bases, and the lateral area are the four rectangles that wrap around it. So if we look and see what we've got here, one of our rectangles is going to be a 6x4. So if we kind of draw that out there, 1, 2, 3, 4, 5, 6, and then by 4. All right, 1, 2, 3, and 4. All right, so all right, there we go. Okay, so then what we've ended up getting here is we've got another rectangle that's going to be 6x3 that's right next to it. So 1, 2, 3, and all the way across. Opposite of that is going to, oh my goodness, where did that go? All right, let's try it again. 6x3, all right. Opposite of that, we're going to have a 6x4 again. 1, 2, 3, 4, 5, 6. Oops, wait, by 4. Hold on. 1, 2, 3, 4. There we go. All right. Which means the opposite of that is going to be another 6x3. And then we can see right off to the side we have kind of the wings of it there almost. So if this is a 3, then this has to match up with a 4, because again, these two pieces will join together. So that's why we have those both be 4s. And again, this is a 4 to match up with this 4. So that's what we're after. So it'd be a 6 there, it'd be a 4 there, a 4 there, all right, a 3 there, 6 is all the way down, all right. And so what we would end up doing here is to find the surface area, we find the area of each of the faces. So like for example, this is 3 times 4, so that would be a 12, all right. The opposite side would have the exact same thing, all right. There's a 4, that would make this guy 3, so that's also, we'd have another 12 that's there. This particular rectangle would be 6x4, so that'd be a 24. We also would have the opposite rectangle be the exact same thing, 6x4, so it's another 24, and then 6 times 3 is 18, and then you have another 18. So you can see we have 6 faces all together, 1, 2, 3, 4, 5, 6 of them as well. So we can add them all up, so that's a 24, that's a 48, that's a 36. Now we can add those guys up. I'm actually going to add these guys because they're going to come out cleaner here. They're going to end in that 0. That's 60. 60 plus 48, that would be 108. So it'd be 108 inches squared. Okay. That's fine. Again, the process a little drawn out there. Now, what we're really after, and we're going to skip on down here, is the formula that we're after. Now, what that does is that walks you through the formula. All right. The actual formula that you use here is that surface area is going to be, all right, we're going to take the perimeter of the base times the height of the prism and add on to it 2 times the area of the base. Okay, so let's go back to that all over again. All right, we've got perimeter of the base. All right, perimeter of base. We've got the height, all right, of the prism. All right, 2 of them because we got 2 of the bases, and that's a poor B. This is the area of the base. So if we look at this particular shape that we've got, the base a lot of time is if you put in the palm of your hand, that's what you actually end up seeing. So if we want to kind of draw it out a little bit more, that's kind of where your base is. That's this guy that's down there. So to find the perimeter of the base, it's what's wrapping around it. So we can see it's a 10 here, it's a 17 there, all right, it's another 10 there, and then another 17 back there. So we've got a 10 plus a 10 plus a 17 plus a 17. All right, so 34, 54. So 54 is the perimeter base. Now the height, that's the actual height of the prism. So how tall is it? Well, it's a 4. so times a 4, plus 2 times, and then the area of the base. So we see the area of the base, it is a rectangle, so it'd be 10 times 17. So this is where we can actually just type it all into our calculator, be done with it, and come up with our particular answer. And there's nothing wrong with saying 17 times 10 is 170, times 2 is 340, plus, and then 54 times 4. Again, it's just your comfort level. Nothing wrong why you can't reach for the calculator and plug that all in. 556. It is centimeters, and we are squared. All right, kind of went over into the other problem that's there. But that's the whole idea behind it. Now, the reason why the perimeter of the base works is because you are going to have to do a 10 times a 4, and then a 17 times a 4, and then another 10 times the 4, and another 17 times the 4. So instead of doing all those separate individual problems, we can just use the perimeter of the base and then multiply that times the height. All right, so let's try it again here. Again, we've got the perimeter of the base times the height plus 2 times the area of the base. So the perimeter of the base, we got a 7, and then we have a, we're going to use that information up there, that is a 4. So I've got a 7 plus a 7 plus a 4 plus a 4. All right, I do all of that, times it by the height. All right, so that is a 10 plus 2 times, and then the area of the base. We would do a 7 times a 4. And there we go. Again, punch that all in your calculator at once right now. If you want to do the addition and do 22 times 10 first, and add on to it there, your 56. Again, 220 plus 56, or you can, like I said, type it all in at once. So 276, and then we are centimeters squared. Now, even though we're a three-dimensional shape, it is centimeters squared because we are surface area. We needed to make sure we knew area is the number of squares. I know, dramatic there, huh? Oh, my goodness. Okay, so the last one here, this one makes us doing a little bit more work with it, all right? All right, yes, it is a little bit more work with it. Now, the idea is what's the name of this shape? This is a triangular prism. All right, which means there's a triangle for the bases. Now, even though it's not laying down on the ground, that is your base. And you can see this is your other matching triangle. That's what makes it a prism, is that it has matching shapes. None of the other rectangles end up matching each other up. So when we do the perimeter times the height, the perimeter is actually going to be of this triangle. So 3 plus 4 plus, and then the 5, yeah. So 3 plus 4 plus 5 for the perimeter. Now the height. Now remember, the height always connects the two bases. We saw this with our trapezoid. So when the height connects the two bases, there's your other triangle there. What's the number that connects the two bases? Yeah, right there. There it is. So it is a 7. So it is times a 7. Now remember, it's 2 times the area of the base. So 2 times the base. Now the base is a triangle, so that's 1/2 times the base times the height. And the base and the height always meet at the right angle symbol. So that's why I'm going to use the 3 and the 4. All right. Now again, you can plug this all into your calculator right now. You can do a little bit of cleanup here. I'll do a little bit of cleanup. 3 and 4 is 7. 7 and 5 is 12. So 12 times 7 plus, hey, check this out, 2 times a half. Bye-bye. It becomes a 1. Multiply something by 1. It's not going to change anything. 3 times 4 does give me my 12. So 12 times 7 is 84. 84 plus 12, that's 96. I got 96 feet and then squared. So again, you do have to visualize, and that's the thing with these particular ones. It's not just a close your eyes, let's throw some numbers in. You do have to be careful, otherwise things are not going to work out well. All right, yeah, and we don't want that. We don't want it to kind of finish off like that. So we're going to stop you right there. All right. Again, we're certainly going to be working on more of these. We do want to start getting more comfortable with the formula and not just simply kind of piecing everything together. All right. That's all, people.